During this section we're going to be taking a look at some of the simple definitions of acids and bases. Now, your first definition from many years ago was that an acid was sour tasting, which was a very simplified sort of interpretation. So things like lemon juice and vinegar were classified as acids by that logic. Arrhenius was the first guy to come up with a real textbook definition, and he suggested that acids generally produce H plus ions, bases generally produce OH minus ions. This was developed further by Bronsted and Lowry, who were working independently, and they defined an acid as a proton donor, a base as a proton acceptor. If you look at the ammonia in the equation here, it's actually acting as a base by accepting a proton from the HCl. By Arrhenius' theory, this couldn't be a base because it just doesn't generate an OH minus ion. So it proved with Bronsted and Lowry that Arrhenius was in fact incorrect. Now, for Unit 5, you may well be asked to talk about Lewis acids and Lewis bases. Now, a Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. Now, strong acids are ones that are fully dissociated in water, and the four that you need to know are shown on the screen, and it also talks about whether they are monoprotic and diprotic. Now, your sulfuric acid, of course, is diprotic. That means that each acid entity generates 2 protons. Phosphoric acid is triprotic, and each one generates 3. Your weak acids are much trickier because these will be not fully dissociated in water, and generally you'll be given a Ka or a pKa value when you're dealing with these. Now, the rule is the larger the Ka value or the lower the pKa value, then the stronger the weak acid is. Now remember, pKa is minus log Ka, and the only reason pKa is used is to make comparison between acids easier, because it gives a nice range of numbers from 0 to 10 and it makes the comparison much easier. Something has a pKa of 1 and something has a pKa of 6, then the pKa of 1 is a stronger weak acid. And your hydrofluoric acid, salicylic acid, and in any carboxylic acid will be classified as weak. Now, with weak acids, you could be asked 2 things. You could be asked to write a dissociation equation, or you could be asked to write a Ka expression. We'll deal with the dissociation equation first. Now, on the screen I've given an example of a dissociation equation with Ha. Ha plus the H2O gives the 2 constituent ions. Now, that can be simplified to the second equation without the water. Both of those are accepted in the exam. Now, a Ka expression is different. That is based on the equilibrium constant, and is Ka is H plus multiplied by A minus divided by Ha. Now, when you write a Ka, you must include the full formula of the acid. You can't generalise. So in this example, I've given you an example of Ha. If I was asked to write a Ka for ethanoic acid, I wouldn't be able to use Ha then. I'd have to give ethanoic acid and the constituent 2 ions into which it dissociates. And the units for Ka are mole per decimeter cubed. Now, strong bases are ones that are fully dissociated when dissolved in water, and generally these will be a metal joined to an OH minus ion. If it's a group 1 metal, then it'll be monobasic like sodium hydroxide or lithium hydroxide. If it's a group 2 metal, then it will be dibasic, for example, like barium hydroxide is. Now, your weak bases are ones that are partially dissociated when dissolved in water, and generally these will be amines or ammonia, and there are some other examples as well. If you look carefully, you've got methylamine, phenylamine is another example. A surprise entry into this is alanine. Alanine is an amino acid, but is actually a base because of the pH is actually higher than 7. It works out, even though it's an amino acid, to have an alkaline pH. So it acts as a weak base. So they're just general ones that you need to be aware of. But if you can classify them, then you should be okay in the exam in terms of what you're looking for. The examiner would expect you to know everything on this video in terms of its classification as a weak acid, strong acid, weak base, strong base.